Okay, welcome back everyone to another episode of Global AI, the podcast. And today's episode is all about AI in sustainability. I feel like it's been a good little while since I've done a hosting bit on this, not gonna lie. So I'm like, I've kind of forgotten the flow of these things usually. And I'm like, oh, the countdown, just like even that song of the countdown is like bringing back memories. So we're easing our way back into it, folks. But yeah, welcome back. Hope you're having a great start to the year because I think it's been a while, like I just said. But as an introduction, my name is Akancha. I am an AI MVP down here in Melbourne, and I am here joined by a co-host, JK.
Hi everyone. I also haven't been on the podcast for a while, so nice to warm up back into it. I am AI MVP from Brisbane.
Perfect. And I think JK mentioned that he has got a little upgrade happening in the background on his motherboard. So if you hear some slight beeping here and there, that's what that is. But yeah, as we said, it's been a while, but we're really, really excited for our guest today. We've got the fabulous Renee Noble with us today. I was about to start doing the whole like, oh, she works with this and she's in Microsoft this. And I'm like, no, do you know what? I'm going to hand it over to yourself because I think you'll do a much better job of it than me trying to connect all the dots because you wear so many different hats.
That I do. I am addicted to jobs, as some of my friends might say. So yes, why remember all of those? It's a lot of work even for myself. So yes, my main job, I guess we would say, is I'm a cloud advocate at Microsoft in the regional cloud advocacy team. So that means I'm your cloud advocate for Australia, basically making sure we have all the content that you will want to learn to take you on the journey that you want to do with programming languages, with Microsoft Tech, and whatever you want to do there. Whether you're a student, early, career professional, you're all my jam, and I'm here to make sure you have cool content. But yes, on top of that, I have my several other jobs. So as you can see in the background, I have a sign up. It says Connected Code. So I run a business on the side, which is helping schools teach coding better, basically. So going into schools and whether it's teaching teachers PD or it's running a big event. The other week, we went into a school and taught 185 girls how to solve a murder mystery using coding and little embedded technology devices for 3 days. So that was pretty cool. So that's one of my many other hats. I also am the CEO of Tech Inclusion, which runs a program some people might have heard of, much more well-known than Tech Inclusion, which is our new charity. But the Girls Programming Network, which is what we've started this charity up to support, and we've just adopted the Girls Programming Network into our charity, which provides free coding workshops run by women and gender diverse people for girls and gender diverse kids around Australia. It's hard to say how many kids we reach at the moment because COVID makes statistics hard, but I think we could probably teach up to 2,000 girls a year how to code for free, which is pretty cool. So that's one of my other hats. And finally, I spend a couple of hours each week teaching at a high school, teaching girls at the school how to code for year 10 computer science class. So they needed a coding teacher. So here I am. So yeah, I've got a background and I've, worked at the CSIRO and it's startup, ed tech startup. So that's kind of how I've ended up in all of these spaces, which are all kind of about connecting tech expertise with education, with community, and how we can do all that together. So that's my summary.
I absolutely love it. And I think, at the core of it all is really just sharing the knowledge around, which I think makes you the perfect guest to be coming onto a podcast to tell us more about sustainability. So look, I guess in that context, maybe let's talk about that. So why is sustainability so important and why is that such a big topic? Yes, I see it all the time. I see everyone talking about sustainability, but maybe it'd be great to hear from your perspective of where you see it as the most important part of it.
Yeah, I've been interested in sustainability for a long time. I didn't actually go originally to university to do computer science or education or any of the things I do. I went as a chemical engineer wanting to get into sustainability engineering. So I guess that's how I've ended up on this podcast today. And I ended up, I'm going to tell you a little bit about what I did on that while I was there. But yeah, there's just so many applications. And I feel like the world is always, we're focused on growth and, how much more we can do. But honestly, it's kind of okay to just be happy with what you have. Be happy with what you have in your house and your friends and your family. And we don't always have to be growing. In fact, we want to work out how to be sustainable. And, we want to live sustainably. We don't have to have, billions of dollars. I don't have any desire to be Elon Musk or have, however many figure bank account. I just want to have enough to get by, do some nice things that I like. And I feel like if we all kind of tried to move towards that, and also had technology that supported having production, that supported that way of thinking, and, we'd use a lot less resources and we'd support the whole world a lot better, because while we can afford to do it over here in Australia, if we're privileged enough to be able to buy those items or spend more on our electricity and not have to care about the outcomes, really having that privilege is putting the burden on somebody else, because all, whether it's your carbon emissions or the plastic that's going in the ocean or the rising sea levels or whatever, that's impacting people elsewhere, and we might be able to buy our way out of it, but there's a lot of people that won't be able to do that. So I think that's why it's really important to think about this in a global context. I think AI is super great at those kind of broad scale problems where we can apply it to a lot of different, solutions that we might want to come up with.
And I remember you had a thesis on renewable energy. Would you like to talk about that?
Yeah, certainly. So as I just mentioned, I did chemical engineering at university. So I actually went to university to do chemical engineering and chemistry, because I thought I was definitely going to be some sort of chemist person. And it was when I got to university that I actually met a couple of people who thought it would be fun living in college to teach me to code one night. And then I learnt Python, and that's kind of how this whole journey is taken off into the rest of the career that I described. But along the way, I have had to do my chemical engineering thesis. So I had added a computer science major to my degree, but my main degree was chemical engineering, had to do an honors thesis in that. And what that was about, I didn't really want to do any of the things that were on the list. Some of them were like, how can you dry orange juice most effectively? Or please watch this paint dry. Possibly that was really what it was. So I was like, you know what? I don't actually want to do those. I've been learning all this cool machine learning stuff, and I'm really passionate about sustainability. So what I did, I managed to finagle my way into combining those two in a really, interesting thesis, at least to me, about how to optimize your use of solar power in a hybrid electric system. So you're using solar power, you're using the grid to supplement your solar power, and you're using a battery to store solar power through the day. So it's saved up for, evening when people typically use the most power. And what I wanted to optimize was when we get electricity from the grid, because electricity is typically cheapest overnight, at least if you negotiate that way. So this was tested on a variety of models. One was a small community, had a community battery, so 300 people sharing a battery, and then a few smaller sub-communities, and then also testing it for one house. So we tested a variety of different sizes, and basically wanted to see, can we buy the electricity overnight so we pay less money for it, as well as making sure we don't overfill our battery. So when the sun shines during the day, if we get to a point where we are full, then we can't actually use and store that solar power that's free. So we want to make sure we've got enough room in our battery for that, but we also want to make sure we don't run out of power in the middle of the day or in the evening, because then we're going to have to buy power when it's more expensive. So that was kind of the idea behind it, and I can go into the technical details if that would be of interest to you all.
Continue on. This is great to me. As in things you kind of hear about, I've got solar at the house and stuff. I get it, but also I want to know how it all works and where it all connects up as well. So I definitely want to hear it.
Okay, fantastic. So I went, okay, how can we best predict what the battery level is going to look like during the day? So I went and I made a model, because we needed to see not only the total amount of energy you use during the day and the total amount of solar you have during the day, and take the difference of that, because we could do that, but that will only give you the difference for the whole day. But really there's this curve of when the sun is shining throughout the day. And there's also a different bimodal curve of when you're using electricity throughout the day. So actually taking the difference of those two graphs, you can kind of see how your battery level goes up and down during the day. And you want that to essentially stay between 0 and 100. You don't want it to ever get empty. You don't want it to ever get full during the day. So I kind of designed that model to identify that curve. And I did that based on historical data of power usage as well as solar input to see, how much people have typically used for a year period. And then I used that to train a Gaussian process. So to do some machine learning to create a surface, which basically will predict what the optimal day start state of charge is, I'm going to call it. So how much to have your battery charged up at the start of the day. So I did that for basically every day of the year for our demo year to do the training. So we'd used a few different bits of information to also help predict better what that solar input might be, because we could see what the solar input was for that day, but also adding things like wind, precipitation, cloud cover, data on that. We added that to the model as well to give it a bit more divergence on what it might be exactly, because maybe there was some sort of festival on one day and there was a lot more energy used or something, but the cloud cover for that month was probably going to be a bit more generalized. So kind of putting all that in and then mapping it to how much energy, like basically the cost of energy that you'd need to use to have the optimal day start state of charge. So we wanted to map those together to be like, okay, what's the best point to start on for a day that has this temperature, this precipitation chance, and this day of the year? So yeah, that's kind of what the model was based on. And then, yeah, it actually had some pretty good outcomes. So the idea is we wanted to get it to a point where the thing that we wanted to optimize was minimizing how much it cost you, which is also going to maximize how much solar you're using, because that's free. So it was actually, yeah, really good, especially for the 300 group pod. So they would save, you wanted to get it as close to having the optimal day start state of charge. So if we knew exactly when you were going to use power and exactly when the sun was going to shine, that would be our optimal. And I got it to be about 8% off that. So you would only pay, I think it was $33 more a year for your power usage than the optimal based on that statistic. $33 per household. So that seemed pretty good to me. Yeah, so that's kind of the idea that was behind it and how, machine learning brought it all together. And of course, that was just an honors thesis. So there was a lot more I could have gone with. Like, for instance, I didn't go out and buy historical weather predictions. We just had, what this day last year was like. And rather than actually having it predicted based on, well, we think tomorrow it's going to be raining or something, which would be a much more close prediction to what we would, actually have. So that's what we could actually use, to predict tomorrow's weather better than last year's, June the 9th or whatever last year. It's probably better if we actually consult the weatherman. So yeah, but that could possibly lead to some better outcomes.
Yeah, and if I understand correctly, this is to charge battery?
Yes. So yeah, this was basically, we've got our big solar battery, and we want to be able to grab all that solar energy and put it in there, because we're not actually possibly, well, at least pre-COVID, we weren't home all the time during the day using that electricity. So yeah, we want to put that in the battery, but we don't want to fill up our battery during the day. So we don't want to reach 100% and be like, oh, where am I going to put this free energy? I guess I've topped up too much on, more expensive energy overnight.
Yeah, I have kind of two small questions about it. So basically, this model could kind of be translated into, those I don't think it's solar panels. They heat up water. It could be a very similar model for that as well, right? It could work very similarly.
Yeah, I think so. Like, yeah, the solar thermal, are you thinking of?
Yeah, I think so. Yeah.
The solar water heating. Anyway, anything with the sun.
Yeah.
Or other kinds of data, like if you want to do wind power, I think there'd be stuff that would help you predict how much wind happened at different times of the year and what your optimal battery input would be for that. So I think, yeah, it's fairly applicable to a wide range of things. Yeah,
and maybe just for a little brainstorming, essentially you have a lot of batteries at home where basically based on how much you use them and how much they have the capacity and all of that stuff, you could optimize the charging. Because if you don't use something for a long time, you could just not charge it for quite some time and not spend electricity, essentially.
Absolutely. Yeah, so you could possibly like save that for charging, at the end of the day. Maybe like, oh, well, I don't need to charge my laptop because I only need it tomorrow for work. So maybe I just leave it on a system that will only charge it when I know how much energy I'm actually going to have left for the day, and if I can use my battery or if I should get it from the grid when it becomes cheap again.
This is so interesting. And I'm also laughing when he said Gaussian, and I'm like, what is that word and why do I know this? And I'm like, oh, basic maths that I did a whole degree in. That's why I know it. I was like, triggering words here that you're throwing out, Renee, I'm not going to lie. But
yeah, I had to do a lot of revision of first year linear algebra because I did fine in it, but I didn't do amazing such that 4 years later in my 5th year that I remembered it enough to implement a surface modeling thing with multiple dimensions. So I did 50 hours of online courses just to get close enough to knowing what it was to implement the Gaussian process.
That is brilliant. I was just like, oh my God, words. No, not again. But I think it's so interesting, especially, and from a kind of everyday point of view, I'm sure, Australia, there's so many people who are constantly having to use solar power and they've got their solar panels in place in their house. I know for me, I get paid every month from the electricity bill rather than having to pay an electricity bill, even in the winter months. It's brilliant and I am so about it. But when you mentioned the fact that hey, we can actually optimize it even further and put away again all these other parts of it, any little bit can be even. I'm like, yes, unreal. And it's, again, maybe you probably know the answer to this, but I'm assuming parts of it are done by electricity companies at the moment when people have solar panels at place, and they are, I'm assuming, doing some kind of algorithmic work in the background of how much is going to go where and how it's all being used on the grid and when it's being bought back and things like that.
Yeah, I don't actually know if they use any sort of AI model. I assume they have some sort of modeling for sure to know this is how many people we're going to have using the grid at this time, because they have to have those coal-fired power plants started up because they don't start up in a jiffy. So they need to know what that load is going to be in advance. So I have to assume that they have something. Maybe they're using AI, but maybe they're not as cool and up to date as us, green people with solar panels. I wish I had solar panels that they would pay me, but I can't put them on my apartment balcony.
Honestly, it is absolutely life-changing, and it's one of those there's so many grants. If you are listening and you're always want, there's so many grants right now in Australia to go get solar panels done in your place. It is genuinely the best thing I've ever, the best financial decision I've made in the last year, I'd say. But coming back to the bit that you kind of start touching on it, which led me to the perfect next question. But yeah, okay, they're not using the AI or algorithms part of it, but I guess this kind of pivots into that question of where does AI fit in? So you've kind of covered that aspect of hey, we can actually predict and optimize these certain parts of usage, and how do we make a better decisions on how to use our data, the energy that we're leveraging, avoiding those coal plants that are being constantly fired up. What other parts of it can AI make a little bit more efficient or even optimize? Or even the opposite end of it, and I know we kind of said that at the start before we kind of came into the actual discussion, maybe what parts of it are there that AI can't help with at all? Because I think that's just as important to talk about, because people are like, AI, it'll fix everything. And I'm like, no, it really can't.
It's got an acronym, how could it not? No. So yeah, I guess I'll start with that. I actually have a friend who's the CTO of a company called Grid Cognition, and they do optimizing layouts and various toolings for people to install large scale solar systems. Maybe you're a petrol station and you're you know what, we should probably get some solar because people are probably going to want to charge their electric cars or something. That's the kind of stuff that they help with to make sure they get the right scale. But they don't use any AI, because sometimes you can just use maths, just like regular maths, and people haven't done it yet. People are always like, oh, I have to do something really clever to change the world. It's like, no, just do something. Like, just go and do it, even if it's just regular maths in a regular website, and just talking to people about how using maths you could fix their system. So I think that's a really good starting point of like, you can just fix some stuff with some regular, regular code, some regular maths, to start making a difference without having to be like, oh, I'm going to have to learn all this AI and machine learning and what a Gaussian process is and neural nets or whatever. I'm hit a lot of buzzwords. How am I going to make a difference? Like, maybe you already have the answer, especially if you have knowledge in that topic area. You could get into it and be like, how could I optimize this with just maybe some basic graphing or whatever you want to do? So yeah, that's one side of it. Then it's like, well, what else can we do with AI? So it's not all electricity production. Like, we could do a bunch of different things. So I actually looked in well, what are we doing at Microsoft with AI? And I found this clean water AI project, which seems pretty cool. So I guess I'll tell you a little bit about that one, which is basically about how to maintain water quality across a large, distributed network, to protect it from contamination by bacteria or dangerous particles that would cause us a health issue. So the idea was how can we detect the water contamination issues with an AI model? So it's trained to recognize, using high definition cameras, it's trained to recognize harmful particles and bacteria. And then you can train up this model on the cloud, and then you can distribute all these edge, Internet of Things sensors all around the network, where you probably, I don't know how they normally take water cleanliness measurements, but it's not normally until people start getting sick that they check the water. So we can kind of prevent people getting sick in the first place by having these things just operating all the time. I don't know if you have to go take a water sample normally, but that takes, human time to go and collect that water, take it back to the lab, then, investigate it. So having having sensors just doing that all the time, I think is just a really great way to circumvent people getting sick in the first place and having to be the canary in the coal mine. So yeah, that's one cool thing that people are already doing with AI, and that's just a preventative measure. So I think there's a lot of things like that are out there that you can start doing and seeing already. So it's not like the future is coming. It's no, people are already doing it already, which is really cool.
That's awesome. I actually wanted to ask you about how Microsoft is involved in AI sustainability. But I might ask you another question, which also kind of involves Microsoft, is when we're trying to do AI for sustainability, we also need to train the AI. And that tends to actually consume a lot of electricity. Is Microsoft or other companies working on solving that problem?
Yeah, so I don't know what Microsoft's specifically doing, except for making better software and better hardware, which I'll get to in a second. But yeah, there is a big, it's not as bad as some other technologies, not naming any names like blockchain or something, that are really terrible for the environment. But there is a lot of energy consumed in training some of the models, especially something like the Megatron language model uses almost as much energy as 3 households do in a year in its 9-day training period. So that's a lot of energy, but it's kind of a one-off cost is the other side of things. And that's a language model, so that's one of the biggest, hardest to train upfront kind of costs that you have. So that's, there is a big overhead of that, but it is just a one-off cost, if you get the training right the first time. But then you can also use things like AI to circumvent that, some of those issues. For instance, Google's DeepMind uses its machine learning to reduce cooling energy requirements in the Google data centers by 40%. So it's worth the overhead and that upfront cost if you can use it later to then fix the problem. So yeah, can be bad, but if you get it, trained correctly, then you can it's just, one-off, calculations that are kind of your normal mathematical query that don't take, a lot of energy at all. So it's kind of, once you get it set up and you got it right, it's really worth it, I would say, in the long run.
Yeah, and there has been two things that I have seen that they worked on to fix this problem. One is to put the containers literally on the water, which solves the problem with cooling. It's much cheaper to cool, and somehow ends up even being more reliable. Not sure how, but it's statistics, I guess. And another thing that is very trendy right now, which may or may not impact the training, is a lot of devices now come with AI chips built in,
Yes.
especially the ARM ones.
That was on my list of things to mention. Yes, the NPU. Yeah. Are you talking about the neural processing unit?
Correct, yes.
Yeah. Very cool. Yeah, no, I just started hearing about them at Build. I was like, I didn't know there was an NPU. If we're focusing our chip dedication and having specific chips that are optimized to run neural networks or whatever kind of processing, we're going to cut down the energy because just the routing of those systems and stuff will just make it more efficient. And if you're more efficient and you have to run for less long because you literally have fewer centimeters to go, then you're going to need less cooling and a whole bunch of less stuff in the long run.
Yeah, and what's really funny about this is our phones actually had some sort of AI chips for some time. I just don't think they have been much utility yet, but with AI chips coming to laptops and tablets and basically everywhere, even I think on the cloud, I think we're going to get a lot more mileage out of them.
Yeah, I do actually know what the NPUs in your phone are used for typically. So there's a pre-trained model for working out how your photos could be optimized. So your phone's not doing any training of the model, but it does query the model that's oh, well, we could just, improve your photo by making the background lighter or, improving the contrast or, those kinds of things. So that's kind of what they're being used for already for image processing and optimization.
The fact that I use that feature on a daily basis and never thought about the fact that it's AI on the edge kind of makes me want to die a little bit and pretend I'm not a data scientist. But I think this is kind of the aspect of it, right? AI and in general has infiltrated all aspects of our lives to the level of where people are getting to us and AI can fix it, AI can do it, there's an ML model for that, I can do it. And you're seeing it so much more often. And this is such an important point you're raising, because machine learning and in and of itself, the word has it, it's a lot of machine power that's powering it. And people forget that there's machines actually sitting in a data center that are running this on some kind of energy that needs to be powered. These are the little things that kind of people keep forgetting about, I think, in these conversations, where it's become such a nomenclature where it's just here, it's everywhere, it's good to go. In that context, what do you think the biggest challenge for kind of AI in sustainability is going to be?
So I think the energy costs are a big issue, but also model fitness, because if you overfit a model, you end up with one that can't do a generalized case. So for instance, for cooling a data center, as we mentioned before, if you overfit that model, then you can cool that one data center that you've trained it on. But you wanted to cool another data center, you're going to have to train a whole nother one. So you have that overhead multiple times, when maybe, if you think more about, the parameters that you're including in your training and having, more people need to be involved in this, because we also, sometimes make AI that doesn't do a good job because we didn't think about what we were giving it. So that, we can get into the ethics of AI and things, and people using AI not necessarily for good. So not targeting sustainability, but, doing any application of AI, you should be thinking about, well, firstly, is this a good thing that's going to make the world a better place, or am I giving it biased data that's going to, help maintain the biases that exist in society? And maybe you could just get rid of those parameters that were about gender or race or class or anything like that, because you don't need them, and it would make your model better for the world, as well as having, fewer dimensions that you need to then model, which adds, a whole bunch of complexity. They kind of all add up together. So if you could, get rid of some of those, and then also consider, how to best optimize for a general case, for cooling a data center or something like that, then we can train fewer models and then just reap the benefits of, using those models to cool data centers rather than training more and more for every data center that we pop up, because we need more and more to do all of our AI that we're doing. So it's kind of, a chicken and egg problem. But if we can, cut the cycle, we could do a lot. You could do a lot better.
Yeah, I think, oh God, like even just everything we talk about, I think I was at a conference yesterday, which is wild that we're back in person doing conferences. But this is something we talked about, right? Like the whole aspect of that diversity and stuff. And I swear, I mean, if I start talking about this, we'll end up on a 3-hour tangent on this. But it is so important to mention that. And I think if your model doesn't need 50 different features and it actually only needs 3, use the 3, because it's also going to take less computing power to train it on those 3 things and make it more generalizable so that you don't have to train another one. It's just like such a compounded effort of like, yep, you're making it better because it's not judgy as hell in this model, but it's also better for the environment. It's just so many compounded efforts at the end of the day, that I'm glad you mentioned that.
Yeah, and I'm going to ask you a bit of a closing question now. Something a little bit more broader for some people, what they can try to do. For instance, if they're thinking about home automation, or they're thinking about, hey, how can I help? I'm at home, I have lots of electrical devices, but I don't have, for instance, solar panels. How can I help with sustainability?
Yeah, so I guess that kind of comes back to what we were talking about before. So maybe you're charging your devices at a different time of the day. Depending, maybe you do have solar panels and you want to optimize how you utilize those. Then, like the model that I created in my thesis, like 23-year-old or whatever me could make the model. And there's way better technology now. I really wish I'd used like something like Azure's machine learning studio, and rather than coding it by hand with Python and NumPy and scikit-learn and everything, it would be much easier these days to build something like that that could optimize your solar power, battery containment, etc., using other data that personally about your own house as well. Because you might know, oh well, I know I use the kettle a lot, or I use this a lot, or I use the TV a lot, and you could include features like that to help you understand what your load is. Like, oh well, we'll keep the day of the week because Sunday's party day and everyone comes around and we play video games all day or something. So utilizing things like that could be like definitely applicable on the home scale. Like having more houses in my mini network with a shared battery did make it more optimized. So the 300 house collective was much better than the single house collective, but that's really because of the uncertainty of what's going to happen to an individual house compared to like the average that happens to the 300 houses. So if you want to model something based on like, energy usage or water usage or something that more about your own house, and you have some data that you can use on that, then yeah, I don't see why people can't just put something together that works on such a local scale that'll help optimize your electricity bills personally, and cut your carbon emissions.
Yeah, I kind of hope that someday I'll be able to just program my dryer to just start whenever my home is a little bit cold, when I have load in it, because it does heat up the room a little bit. So that would be really awesome. I'm currently doing a little bit manual of that. So okay. Around about 9 p.m. it's getting pretty cold, so I turn it on and I open the door, so it's a little bit of heat, especially now in the winter time and in summertime, and trying to do it very much in the morning before it heats up and I go home, go to work.
Yeah, I guess there's like no reason you couldn't use some sort of like IoT devices as well. Like for your home optimization, some like my friends have, a readout of like how much energy is being used from their solar battery or from their solar power system. So they can like just have an idea and awareness of that. But, maybe you could hook up something to your aircon system that optimizes how energy is used throughout the day. So it's like, oh, the sun's come out, let's turn the aircon off because we don't need it. We don't need the heating right now because it's sunny, and things like that. So just like simple things without AI could really make the system good. Better for you, your electricity bill, the world, society.
I'm going to point my dad to this episode because literally this week he's complaining. I mean, yes, inflation's a thing. Everything's going up in price. And he's like, we need to stop using all these things because I refuse to pay for it. So I'm like, here you go, Dad. This is how you can optimize and not pay for as much of it, but still keep us from freezing to death every night. That would be an absolutely great episode. Sorry, for context, if Dad does listen to this, I'm not saying he freezes us to death, but you get the point. Look, Renee, thank you so much for your time. We will wrap it off there. And look, I think we all kind of get the idea that Renee likes to talk and explain things to other people. So if you do have any questions, I'm sure Renee will be more than happy to answer them. Or realistically, there's somewhere that she's already answered them. So definitely go give her a follow. She's like legit. Every other week, I see some new content coming from Renee, which is always really, really exciting and interesting to see. So make sure you do go give her a follow up. And if you have any other questions, reach out to us. But look, in the meantime, we're going to end it there. We'll be back again in another month's time with another episode of the podcast. It'll be some fun, fabulous, new, interesting point and topic with AI focused around it all. But for tonight, this is it, folks. Thank you so much for your time, Renee. I really, really appreciate it.
Absolute pleasure. It's been great talking to you all about changing the world.
Exactly. This is it. I want to hear people like absolutely changing it and like reducing their reducing their optimizations. No, reducing their energy by optimizing. That's what I want to hear. So if you do end up doing that, reach out, let us know.
Awesome.
Increasing efficiency.
Exactly.
That's it.
Perfect. See you soon, folks.